I am Li Wong. I'll be running this class for the most part. Nice to see you all here today. What you see on the screen, this is a CAD simulation of appropriately called a do-nothing machine. This machine really doesn't do anything. Basically just slides a little block back and forth, but it has some very interesting properties. It shows relations between the two blocks sliding back and forth, and with all the constraints applied, since it's sitting in a dovetail groove, this actually simulates a physical device. We actually could 3D print this thing if we see appropriate. And what this is a assembly tool in Onshape. We'll go over that eventually, okay, in the course of our class. Not necessarily today, but you will be able to do this by the end of this 4 weeks class. Okay. Yeah, something to look forward to. So let me stop that. Let's get our presentation started. Okay. Everybody can see this, right?
Yes.
Okay, great.
Yes.
Excellent.
Yes. I have a question.
Okay.
So, are we supposed to like have a computer to be on?
Yes, but if you cannot get your hands on one, I guess you can use the iPad. The method of how to do things is a little bit different. So
Okay.
hopefully you can get as much out of it as a PC. If you have a computer, it would be better, yes. Okay, who asked the question anyways? I didn't catch your name.
This is Michael.
Michael.
Yeah. Michael was in the previous FAL junior team. Yeah. I invited him to the class today. Thank you.
Okay. So let's get going. Today is basically a general introduction. We'll go over a little bit of histories about 3D drafting and some 3D printing stuff. And I can demonstrate a few pieces of 3D printed things that I made along the way. So just give you a little bit of a demonstration of what's to look forward to. And 3D printing has been available for some time now. But if you're not able to make your own design, your own part, and you're limited at downloading other people's designs, that can get boring quite fast, I think. So if you're able to design your own part, design your own material, that makes it more interesting, and that's possibly a little bit more useful along the way, okay? For instance, you have a toy that's broken, or somebody needed some part that needs to be made, or say a paper towel hanger that your mom could use, right? So you can design something, make it yours. That makes it more interesting, if you ask me. So I'll go over the software stuff too in a little bit, okay? Okay, this class is hosted and sponsored by Academy of Excellence. So we thank Ms. Karen and Dr. Young for our this platform that we can use. So the staff of our class will have 3 instructors, Mr. Wenyu Tang, me, Li Wong, and there's Mr. Zhao. I'm not sure he can make it in today.
He is here.
He is here?
Yeah.
Okay. And can the coaches say hi?
Hi everyone. I'm a temp when you temp.
Hey everyone, I'm Zhang Zhao.
Okay. Well, welcome all, welcome all. And we'll have a couple of administrators. Karen is actually the principal of AOE, I believe. And Vicky Lee, which is my wife, and she's been running some background stuff for the class and doing some recruiting and make this stuff possible. Basically, all administrative stuff will be handled by Ms. Karen. And if you have any questions along those lines, please do not hesitate to ask her or have your parents email her or WeChat her. There are ways to get in touch, okay?
Hi everyone, thank you, Dr. Coach Wang and every coach. Thank you.
Right. So can we go around the room, have everybody, talk a little bit about yourself, what school you go to, what grade you're in, name, and let's, Ms. Karen, can you do the roll call, please?
Yeah, thank you. So please turn on your camera. Let's go by Leon first. Leon, you go first. Turn on your camera, please. Leon, please unmute yourself.
Hi,
Introduce yourself.
I'm Liam Wong. I'm 9 years old. I'm in third grade. I'm going to fourth grade. I go to Matsunaga Elementary, and I'm learning how to swim.
Thank you, Leon.
Thank you.
Next one, Kevin Tang. Kevin, you are here, right?
Yeah, so my name's Kevin Tang. I'm 9 years old. I'm going to fourth grade. And I go to the same school as Liam, Matsunaga.
Nice, thank you, Kevin. So
Welcome.
Jingwei is not here yet. So next one, Will. Wilson.
My name's Will. I'm going to sixth grade at Kingsview Middle School, and I'm 11.
Okay. Hi, Will. Good to see you again. Sam. Sam Isa. Sam.
Hi, I'm Ethan Block, and I go to Frost Elementary. I'm going to sixth grade, and I'm learning how to program right now.
Okay, that's awesome. Thank you, Ethan. Okay, so next one, Sam. Sam, you are here, right?
Yeah.
Okay, your turn to introduce yourself.
So, I'm Sam Isho. I'm going to sixth grade. I'm 11 years old. Yeah.
Which school do you go?
I'm going to Tacoma Parks.
Okay, welcome, Sam. Good to see you again. So, Seyoung.
Hello, I'm Seon. I go to Roberto Clemente Middle School, and it's been exactly 5 days since I'm turned 13.
Wow, nice.
Happy birthday.
Happy birthday.
Okay.
Hip hip hooray.
Seyoung. Next
I
one.
gotta say, I'm not really feeling it as of the change from 12 to 13, but okay.
Okay, so next one, Daniel. Daniel Lee.
Hi, I'm Daniel. I'm 14 and I'm going into ninth grade.
Okay, well, can you tell us which school are you going?
I'm going to Thomas Jefferson High School.
Oh, you're far from here. Okay, welcome, Daniel. So next one, Janice. Can you introduce yourself to us?
Hi everybody, my name is Janice and I am 8 years old and I go to Stone Mill.
Okay, welcome, Janice. Okay, Carrie. Carrie Lee.
Hi, my name is Carrie. I'm 12 years old. I'm going into 7th grade and I go to Hoover Middle School.
Okay, welcome, Carrie. Nice to see you here. So you have your sibling here, right? Hannah.
Hi, I'm Hannah. I'm 11 years old. I'm going to 6th grade and I go to Hoover Middle School.
Okay, welcome, Hannah. So next one, Charlie.
I'm Charlie. I'm 10 years old and I'm going to 5th grade at Clear Spring.
Okay, welcome, Charlie. Next one, Olivia. Olivia, can you please unmute yourself?
Olivia, and I'm signing in my mom's account, and I don't want to say anything.
So which grade are you in right now? Okay, we'll come back to you later, Olivia. So next one, Hagen.
Hi, I'm Hagen. I'm 13. I'm a rising 9th grader and I'm going to Winston Churchill High School.
Okay, welcome, Hagen. Good to see you again. So Jenny.
Hi, my name is Jenny, and I'm 8 years old. I'm going to 3rd grade, and I go to Falls Mead Elementary School.
Nice, welcome, Jenny. Next one, Jacob.
Hi, my name is Jacob. Today, I'm 8.5 and I go to Matsunaga Elementary.
Nice, so welcome, Jacob. Next one, Kylie.
My name is Kylan and I'm going to 4th grade and I go to Matsunaga Elementary.
Welcome back, Kylie. Good to see you here. So the next one is Michael. Michael? Michael, your turn.
Okay. My name is Michael. I'm about to turn 8. I'm in 2nd grade. That's it.
Okay, thank you, Michael. Welcome. I'll turn to Coach Wang.
Great. Thank you, Karen. Welcome, everyone. Hopefully, we'll have some fun together in the next few weeks, and you know, learning how to draw, how to print. You know, could be interesting. So it seems like we have a fairly large expanded age groups here. So we have 2nd graders all the way up to almost high school kids. So yeah, welcome all. So the goal, what are we trying to get out of it at the end of the 4 weeks? So basically, I've already kind of mentioned a little bit earlier that you all should be able to generate your own 3D models, and corresponding drawing sets, and assembly, and virtual assemblies. And they should also be able to generate and understand a 3D printing, have a general concept of 3D printing, and should be able to generate a printable slicer file as your model. Since 3D printing is involved in this class, and you will get a little bit of some, right, at the end of your course, and hopefully it's something of your own design, of your own drawing, okay? And I have to do this pretty much every class. Basic rules and behavior expectations. Follow classroom rules in general. Respect all staff members and your fellow students. Raise your hands if you have a question, and please be patient. The instructors will get to you in turn. Avoid crosstalk, and we'll have a little bit of discussion between time and time. Just make sure only one person speak at a time. Since we're doing this online, cross chatter will make it really unbearable very quickly. You know, it's difficult to understand people. And by all means, do not try to all talk each other, all right? Avoid annotate on shared screens when somebody else is sharing a screen, and stop drawing stuff on their screen when it's not necessary. If you're trying to make a point on that during discussion, feel free to do that. So that's why I didn't disable the screen annotation. Occasionally, I'll ask students to share their screens to show their progress. You know, how much have you learned? Were you able to generate drawings? Sorry, give me a sec. No. We can play here. Right. While your fellow classmates are sharing their screens, please be considerate and also think of it as a learning experience. Sometimes they may have questions you don't have answers to. So this will help you out as well, okay? So let's go over a little bit of brief history of computer-aided design. So general drafting is also called CAD. That's what CAD stands for, is computer-aided design. And sometimes it goes with two Ds, C-A-D-D. The other D stands for drafting, computer-aided design and drafting. This all started back in about the 1960s when IBM's drafting system started design and implement software to use computer technology at the time to aid in drawings. And before then, you would have a floor of engineers doing all kinds of drawings by hand, especially in the automotive industry. So from initial concept and drawing of the vehicle to the final drawing set, this could take a very long time, and was an army of engineers checking every single dimension, every single aspect and of the design. And oftentimes error checking is very, very time consuming. So it was sought at the time that computer technology has begun to come into the picture in the 60s. And as most of us already know, the computers were initially invented during World War II and for basically code cracking, right? When enemies talked with each other. So if you're trying to intercept enemy communication, oftentimes coded, so sometimes the algorithm could be very complex. So a mechanical computer was necessary to either translate normal communication into code, and also some kind of computing device to decode So some of you might have heard Enigma machine, which is a German top secret mechanical computer at the time, which their submarine commanders used to communicate their locations and orders back and forth, okay? And this wasn't until almost at the end of the war, before the Allies were able to capture a few Enigma machines, actually was able to decipher German communications. And that, in no small effort, is what turned the war around. Once the Germans no longer have secrets to keep, and all their orders and locations were announced openly to the Allied troops, and they just became sitting ducks at that point. So what are the benefits of the CAD systems over manual drafting? There's capabilities one often takes for granted for computer systems today, because computers today, what's on your desktop is much more powerful than what they had in the 60s or 70s or 80s for that matter. Your laptop or desktop you're using now can easily defeat a mainframe computer of the 70s or even 80s in computing power and speed. So as you can imagine, drafting has came a long way, especially with 3D drafting. Is very computational intensive. Just the simple task of rotating a model around into different phases the computer has to do hundreds, if not thousands, of calculations. Nowadays, even with your laptop, those calculations seem done almost immediately, instantaneously, but it's not, right? So needless to say, CAD software has revolutionized, made revolutionary changes in the engineering industry. And versus a room full of engineers drawing, spend months at a time, if not years at a time, to complete a design. Now you can have a single person sitting behind the desk with a computer and does the job of a room full of computers in a matter of weeks, if not shorter. So in general, there are two types of drawings. We can have 2D drawings, which is usually in the mechanical setting, a representation of a 3D object. So how do you use 2D drawings to represent a 3D object? So you do it usually in 3 phases. You have the front view, the side view, and the top view. Sometimes you need to show internal structure of a 3D object, then you have to use a cross-sectional drawing. So basically, imagine if you cut a watermelon or a cake in half, and that specific 2D drawing will show what is the cut section looks like. Okay. But 2D drawings has some advantages over 3D drawings as well. So in the 3D drawing, sometimes, depends on what phase you're looking at, it's difficult to see what dimensions are, right? So why are drawings necessary to start out with is not just for the designer to know what it looks like, it's also the people that makes the parts down the road. So they have to know exactly how long a certain line is, how big certain hole is. And in the 3D drawing, sometimes gets really busy really fast. And since there are parts covering each other in the 3D view, oftentimes it is necessary still to use a 2D drawing to show the exact dimension of everything you have designed. One very large advantage of the 2D drawing is the use of much less computer power and storage. 3D drawing can easily run into tens of megs of storage space because it has a lot of information to store. Each phase of a 3D drawing will require different data to tell the computer what it means. In 2D drawing, however, you only worried about a single cross-section. And sometimes a 2D drawing can convey the same information as a 3D model. But you would require a little bit of drawing reading experience. So this is what's referred to as an 80-20 aluminum beam. It's a structural beam that is modular. See the trapezoidal shapes, you have locking keys that goes with them so you can mount different things on it. You have a hole in the center to line it up. So this would be a perfect example of a 3D model of a given object. This will be a 2D drawing of that same object of the single phase, right? See, with this drawing, you'd have all the details on how round the corner is, how long each of the legs are, all these little lightning cuts, okay, what the radius of those are, and also specific dimensions of different angles, different lines, different holes. The hole in the center, for this instance, is 1 inch in diameter. And the gap difference here is 0.792. So they have the very detailed information on a given subject. So if you go back to here, you see a nice 3D drawing, but it's kind of hard to find out what the dimensions are unless you have a computer program that can actually measure it. It is not shown very well. And over here, and you can see that. So there are advantages of either system. to show what it looks like on the inside, talked a little briefly about a section drawing, right? So A points that way. What that means is it sliced this model in half and looking in that A direction. So section AA shows what that looks like. The little diagonal lines that goes down the chain there, that means it's solid. Okay, so you have a solid side and some the core hole right there and some other side over there. So why 3D modeling? Design and assembly in virtual space saves a lot of time and money. So oftentimes it can simulate how all the mating parts go with each other. And before you send it out for prototyping. If you recall the model as shown in the beginning of the class, now that is a animated simulation. And if you look closely on the individual phases, and you can actually see the tolerance of how much gap is in between individual parts. So if you're trying to put a part into a mating surface of exactly the same size, would it fit? The answer is no, okay? So you have to have a certain amount of loose tolerance for the parts to work with each other. If it's so tight and with no air gap in between, they will not fit. So this is a video of such practice, right? This is a little bucket with a clip on the side. So you can simulate how this clip will fit into this buckle in the software before you ever make it into either a 3D printer or a other manufacturing capability. So in this view, if you zoom in a little bit, you can see the gap. So you make sure everything is going together nice and smooth, there's not binding. So in the design process of the part you're trying to make, you have to keep some of that in mind. 3D drafting became more accessible and cheaper in more recent years. 3D printing became almost the next natural progression. 3D printing, what is 3D printing used mostly is prototyping. What does prototyping means is when you design something, you have to make a sample piece to make sure everything goes together, everything works with each other. And oftentimes, if you do not have the 3D printing capability, and you actually want to make sort of plastic parts mostly, you have to make a mold of the part you're trying to make. And if you find out then some things didn't fit, you have to go back several steps. You have to remake the mold, you have to redo the design, and you can imagine the expense will build up very quickly, okay? So any kind of fault in the design, if you have to wait till the manufacturer to tell you this doesn't work, that doesn't work, the redesign can be very costly. So 3D printing came around just in the right time. So now you can relatively cheaply 3D print something of a solid part and put it together, see if it works. If everything works, you proved that the prototype works the way you want it to, and then you can send it to the production company to make the mold, to inject the actual material to make the actual part, right? So that saves money, saves time, and saves material in the long run. So the 3D printing is simply used for prototyping? Not necessarily. As technology gets more advanced in the industry, 3D printing is becoming more and more popular. I'll show you a video of actual industrial size 3D printing in action in a few minutes. Now, how does 3D printing actually work? You all probably have printers in your house, right? That's basically a 2D print. So the printer head laid down the image of what text or what picture you have, and transform that onto a piece of paper. Now, a 3D printer does it in a very similar manner, only in 3-dimensional. So how does it do that? It puts down material one layer at a time, okay? I can show you a quick video. This is the machine we'll be using for the course. This is a FlashForge Creator Max. It's a very capable machine. So this job is already, print job already started for a little bit. So you can tell the bed moves down every new layer it puts up. So over time, you see this little part gets bigger and bigger and bigger as the bed moves downwards, okay? Now, since the nature of a 3D print, it is not perfect, right? This is generally what a 3D printed part looks like, since it does it in layers. Now, you can see on the yellow part, rather the light green part, this is the base of the print, and then it builds each layer at a time to make up the 3D object. So the quality of the 3D printed part sometimes is of question. Depends on the material, it might not be very strong. And also the mating surfaces could be really rough. So to design something to be 3D printed, sometimes you have to increase the tolerance of the parts, meaning make the gap a little bigger, right? The mating surfaces, if the actual metal or plastic part made out of actual material or injection molding, the tolerances could be a little bit tighter than what 3D printed material can be. You can see the gap down in there's two gears here, the blue gear and the green gear. The gap is actually rather significant because for the 3D printed material to work, it has to be big because the surfaces are not clean. Now we mentioned industrial. Well, to understand 3D printing, there are a few different types. SLA, which terms are standing right there. And this is basically a resin-based 3D printing. So you have a laser that runs on a pool of resin that sits on a building bed. So each layer of the laser will harden the resin layer by layer and moves down, right? So it's very similar to the filament printer we just saw in the video a minute ago. Now, SLS machine versus a liquid is very similar to the SLA machine. SLS uses a powdered material. So you use a laser to harden this powdered material, then go down layer by layer, right? Fused deposit modeling, FDM, does what the general household and desktop or hobby machines are mostly built out of. It runs on a filament, okay? Basically, if you imagine a glue gun, you melt the glue gun a little by a little, and you melt this plastic down, you put down a layer. You melt the next layer down, you put on the next layer. So that's generally how that works. There are some newer stuff called DLP, which is very similar to the SLA machine, is also working on a resin. Instead of one laser pinpoint at a time, it generates a 2D image of this layer. And it hardens an entire layer at one time. So you can imagine it can be a lot faster using DLP versus SLA. And MJF is similar to SLS. It's powder, but it's faster. Polyjet is a multicolor material, and just in more recent years, you can actually print metal material, okay? So there are a couple of different types. So this is the video I promised you. This is a large-scale additive manufacturing machine. This machine is capable of extruding and making a part And then since we talked about a little bit earlier about how rough the surface can be on the 3D model, 3D printed model, so this machine has the capability of routing as well. By routing, I mean it cuts off the unevenness. So it has sound. So this is a time-lapse video, so it happens a lot faster than when it happens in real time. And just like in your home office setting or your home 3D printer, and the 3D printing bit size could be limited, right? Although as large as this machine is. Depending on the model, they have to do it in pieces. That's what they're doing here. So this model is cut up into 6 different parts. So once each individual part is printed, you can see the step forming on the surface of the model, right? What they're making here is a shell for a,
It's the hull of a boat.
well, yes and no. They're making an outside profile of a hull, but why they're not actually building a boat. They're using this thing to build a mold for a fiberglass layup mold. So this is when they finish cutting the surface, it's nice and smooth. And this is the finished product. So 3D printing has, the whole point I'm showing in this is there is an industrial aspect of 3D printing as well. So this is the way of the future. Things will be done more and more this way.
Would this have taken a couple days?
This probably took, you're talking about specific video?
No. What I mean is like making the whole, like with the LSAM printer.
Okay. This LSAM printer, this specific model, I'd imagine it probably took up to a week to finish. Because just judging by the size of the piece. This is working exactly the same way as your home machines. It puts down material one layer at a time, only the layering is a lot thicker, possibly up to a ½ inch at one time. But you still have to. Okay. So coming into the 90s to early 2000, and cloud computing became a thing. Cloud computing initially was just for cloud storage, and anybody has a phone and probably already aware of that. You can store your contact information, your pictures and videos up in the cloud. And just recently, even actually ever since the beginning, the thought was not only have the cloud storage capability, you actually have the cloud processing capability. So your computer at home becomes more of a terminal than a computer. So it requires a certain processing capability on your end, but most of the more computationally intensive stuff is actually done over the internet. So with the advent of Wi-Fi, of high-speed internet, so this become more and more possible. So that brings us into the package we'll be using for our drafting part, right? This package, software package is called Onshape. So it is a CAD software system. It's based completely in the cloud. And all you really need is a browser. For those of you that use iOS or Android apps, there is an app you can download that's in Onshape. That's hopefully after you create your account, and you should have access to it. The reason for the apps is you can actually do design changes on the way remotely. You don't have to be working in the office as a group of people. So if you need to make small changes to certain things, you can just do it on the fly. But to draw things from the grounds up, you probably still need a PC because you do need the hardware. So there's a quick video of what Onshape is.
Built from scratch using the latest cloud, web, and mobile technologies to complement the way today's professional design teams really work. With Onshape's unique database architecture, you can build complex parametric parts, assemblies, and production-ready drawings together as a team. Unlike old CAD, data management is built in, so there's no waiting for files to be checked in or checked out, no accidental overwrites, and no expensive PDM software. You can explore new concepts, new ideas, and new design scenarios simultaneously within the same document, merge changes together, and browse every design change ever made, so your entire team can design with confidence. Sharing design data with your team, your suppliers, and even your customers is easy. Simply enter their email address, assign access rights, and click Share. Clicking the link in the email opens your document in a browser or the Onshape mobile app for instant editing or viewing. Sending CAD files in unsecure email attachments is now a thing of the past. For the first time in the history of CAD, teams can work together on the same assembly, same part, even the same sketch for true real-time collaboration. As team members edit or create new features, updates are reflected everywhere, within seconds, so the entire team can see the impact of a design change instantly. With simultaneous access to the same CAD data, design workloads can be shared easily. Every team member, partner, or supplier can contribute in real time with no restrictions, enabling projects to be completed in record time while maintaining full control over your company's intellectual property. Whether your team is located in the same office or across several time zones, Onshape's powerful collaboration tools inspire teamwork and boost your productivity. Teams work better in Onshape.
So if you guys have been in the industry for a little while, you probably have better understanding what that's about. Team collaboration in projects is actually a big deal. And what Onshape does is actually amazing. It saves a lot of time, a lot of heartache or headache. So let's do a little bit of drawing, okay? So today's main focus is to make some 2D drawings and some basic shape and some basic shapes, okay? Turn them into basic 3D shapes. I have generated a document which I'll share in our Google Classroom site. And if you run into some issues, you can look at it. And I'll go into Onshape in a minute, and then we'll do this on the fly, okay? I'll tell you exactly what everything is. So if you run into some issues later on when you're doing your own explorations on your own, if you run into problems, you can refer back to this file. Pretty much everything is on here. If not, Onshape has a very good help library. You can try there as well. So let's get back to a little bit nitty-gritty. So this is the video some of you might have already seen on the website. This is a part that actually I drew. This does not take very long. It uses some of the rather advanced features of Onshape. This is in real time. Hello, we'll try to demonstrate how to draw a bicycle sprocket using Onshape today. It should be a fairly quick demonstration. So to start up, you need to do a quick 2D sketch. Once you have the plane selected, let's draw a few circles. You see
and the outside circle, and the circle where the shaft will go through. So next we'll need to define how big they are. Since this is just a demonstration, the dimensions really don't matter so long they make sense. Okay, inside circle is 0.75 inch, which is 3/4. Outside circle is make it 8. All right, next thing we need to do is generate a reference line. And in Onshape is called a construction line. The purpose of this, so we can include some lining cuts, right? Because the bicycle sprocket is not supposed to be very heavy. And let's call that 2 inches. Once a 3D rendering is generated, these holes will all be cut out. So to make more than one copy of the circle pattern, let's use this called a circular tool, right? So the default setting is repeat it 3 times around the circle. I want to repeat it 5 times to make our sprocket lighter. So once that is done, the next thing we need to draw are the little tooth gears on our sprocket. So we need to draw a couple of lines to enclose an area. Every time an area is enclosed, Onshape does it by itself to define the shape within. So let's call that 60 degrees. Let's find out how tall this gear is and make some definition. 0.28 is a little short. Let's make it 0.4. Let's also make sure that 2 legs of the triangle are equal. Good. So no gear tooths are really sharp at the very tip. So let's put a little bit of a radius on the very top. Let's call that 0.05 degrees. Oops. That's the wrong one. Let's do that again. 0.05 degrees. Here we go. So now let's repeat this pattern around the bigger circle so we can generate enough around the whole wheel. So how many of those do we need? Let's say right now the customized standard version is 3, as you can see. Let's make it 50. So one thing to look out for is make sure these triangle lines do not crisscross each other. So now the 2D rendering is complete. As you can see, it's a 2D shape. On the 3rd axis, there is no image. So how do we make a 2D into a 3D shape? Something called extrusion. Let's see, it's already started doing it. Let's include every little shape that we have. Now you see the gears, but we need to subtract out all the holes that we made. And one more. Let's drag it around a little bit. Look at that, you have a 3D shape. But the bicycle sprocket is really not that thick. So let's call it 1/8 inch versus 1 inch. There you go. Does it look like anything yet that you're familiar with? So excellent. So that's all we have for today. Thank you for watching.
Okay, hopefully that piqued your interest a little bit. This is a house I designed in Onshape and printed using the 3D printer that's in my office. So hopefully through the course, you guys can generate something like that. Not necessarily this exact one. I'll go over some details a little bit later. And this is a fairly simple model. So this was drawn in Onshape. So now, with that said, let's go to Onshape. Has anybody finished signing up for the account yet?
I have already finished my Onshape account.
Okay.
I have.
So
I have.
So do we need to go over how that is set up? Okay, let's do that real quick. All right. So I did generate a Onshape how-to PowerPoint. This is in your Google Classroom site already. So if you care to take to look at it for a minute.
Already opened it up.
Okay, very good. So this shows you the address where you need to set that up at, cat.onshape.com. For those of you that haven't done it, feel free to follow along. And once you're there, it'll ask you to sign up for an account if you haven't done that already. So what you do is click on sign up. That'll get you to a different page.
When it asks us for a school name, do we just put the school that we're going to next year?
You can.
Okay.
Right, so do the educational account. And you pick a student, your name, email, make sure it's a real good email because it needs that email address to actually activate your account. Without it, you won't be able to use it. Are you a student or an educator? So true student, school level, pick your appropriate level. This little checkbox down the bottom here, it asks you to, whether they can contact you, basically try to sell your products. You have to check it, right, to be able to use it for free. So do that. So once you get past that point, it gets you to the next page where somebody mentioned about school name. You can either use your own school or you can use AOE. It makes no difference. So if you need to get the AOE addresses and whatnot, I do have it on the next following page. So this is AOE's URL if you need it. Clarksburg, Maryland. And what do you use Onshape for? You can make up whatever, right? You can use it for schoolwork. You can use it for just 3D drafting in general, learning how to.
Excuse me?
Yep.
I have a question. So, what if you don't have a 3D printer?
No, I have the 3D printer, okay? The idea is we will draw something together or you draw something on your own.
And then you guys can send it to him and then he'll 3D print it for us.
Okay. And there are some techniques we need to learn. We'll do that in a later week.
So can we buy a 3D printer, then learn from this class and then print things ourselves?
You may, if you have the, if you want to, yeah.
Okay.
3D printing is
hard.
Still in the early stages, I would say. As if it's standing right now, it's more of a hobby than a consumer electronics. So it's not like a TV or your desktop like paper printer, right? You just feed it something, it comes out perfect. Now, 3D printers are a little iffy sometimes. There's a lot of adjustments you need to make. Sometimes you need to make your own parts to make it work better. And that's also
you can
part of the fun.
Make
right?
gears and then build a contraption or something.
Absolutely. So does anybody else still need this screen up? You still got all that information for AOE? Anyone needs help to get that account set up?
It's frozen.
What's frozen?
How do you sign up for Onshape?
Okay, that's what we're doing now, okay? So go to CAD.onshape.com. That's the address. type that into your browser. Onshape is browser-based.
Yeah, I'm there already.
Once you're there, you get this page, right?
Yeah.
Okay. Now click on that sign up toward the lower right-hand corner there.
Okay.
Once you're there, it'll take you to a new page. Okay? It gives you three choices: a professional trial, an educational account, or public maker plan.
Okay.
Okay? The one in the middle, which is for Onshape for Education, is free to use.
Okay.
Professional trial is...
Wait, how do you get there?
Click on Onshape. You know the address? CAD.
Okay,
Go to your browser.
Onshape. So, and, getting there.
Okay.
Yeah, and then what? I press enter, right?
Yep.
Okay.
Now, did you get here?
Yeah.
Okay. Click on sign up.
Sign up. Okay.
Not working.
Yeah.
You can stay here for a minute.
And then?
And once you click sign up, you get to this page.
Yeah.
So click on the one in the middle. It says education account.
Education account. Okay.
Yep. Okay.
Okay,
So
so I just do what they say. Okay.
Yep. So now you put in your name, your email. Make sure you have a good email address. If you don't have one, use your parents'. But make sure you have access to it. Or have your parents help you out. So all the fields from here on out has to be filled with something. Okay, if you don't fill in.
And then you press by checking this box. I agree to be contacted by Onshape. Blah blah blah.
Yes, you have to.
Okay.
That's just saying they may contact you for trying to sell you an Onshape product. It doesn't matter. They won't contact you.
Okay, and then you press get started.
Yep.
AOE all caps?
Yes.
When they talk about graduation year, if your year isn't on there, do you just pick whichever one is closest?
Pick the furthest one out. I don't know what that does. It could be limiting to whatever year you have to be in the student. Right, so the latest one, I think the furthest one to give you is 2024. Just pick that.
Okay, thanks.
There's also one checkbox on this page says, you know, I'm 13, at least 13 years of age. You have to check that, otherwise it won't let you do it. So if you're not comfortable with that, have your parents check it. Okay, this makes no difference.
What's the school website called?
For AOE,
What's the school website URL?
the first line under Academy of Excellence. You can spell out AOE or spell out the actual name. So AOErobotics.com.
School URL? Huh? What's that?
URL stands for a basically web address.
Your school, my school's address?
Their website address.
Huh?
Jenny, this is the school that offers the program, the 3D class.
So what is it?
You can use the AOE's class. That's what's on the screen right now. You can use this information here.
So I come see.
What do we put in the title?
The title?
Or the title / position?
Okay, you must pick the educator. You need to pick the student account, not the educator. So go back one page. It says, are you a student or an educator? Pick student.
Why does it say graduation year? Do I need to fill in that?
Yes, you do.
Yes.
Select 2024. That's the furthest I'll let you.
Okay. What are you using Onshape for?
You gotta.
Yeah, what am I using it for? Class.
You can say for 3D classwork, for 3D design, 3D drawings, whatever. Pick one or make some up.
You can.
Mhm.
Huh? Why does it also say I am at least 13 years of age and I'm current degree down below?
Just check that.
Just check it.
Check it.
It doesn't really matter.
It won't let you use it otherwise. So I can show a couple of 3D printed stuff on my other camera here.
Wait, so check everything, right?
Check everything, yes. And also click I'm not a
So wait a
robot.
little.
Of course I'm not a robot.
Hold on. Wait a little bit. Let the coach want to.
Oh, this is the house.
Create account.
Thank you.
I don't know if you guys can see it.
And then it's
Oh, a picture of it. What I need, I already took out. Can you guys see the side screen? Just leave it.
Yeah, we just see one screen now. We didn't see another monitor.
I think I still need the presentation up here for information.
Okay.
So how are we doing? So once you've finished with this page, check I'm not a robot, and let you go ahead and create an account. You need to go to your email that you used. And in your email, there should be a Onshape email, and that lets you create an account.
Should be a
activate
button.
an account.
There should be a button.
Should we make a new document once we're into
Oh, you're already there. Okay, give us a second. For those of you that's already there, go ahead and take a quick 5-minute break, and then I'll work with the rest of the kids that's not done yet. Go back and see if it's up.
So we check back the 7:37. Okay, for the rest.
7:35-ish.
Yeah. Okay, good, thank you.
So does anybody else still have issues setting up the account?
Yeah, Jenny, now it's time for you to ask questions if it's not done yet. Who else has the problem? Jacob, are you done?
Go check your email.
Yep, go check your
Then
email.
it says go check your email. So you just click the link there to act. Also, what do I press?
Jenny, can you share your screen maybe? Coach.
Okay, but
Okay, let me stop mine.
yeah, okay.
Can you share your screen so we can walk you through? So who else has problem?
Do a reboot maybe.
Sam, you're done, right?
Take a look here because there's a bunch of stuff here. Especially this is a wheelie chair.
Can you please share your screen, Jenny?
Okay, got it. This one.
I missed something.
Well, you're done, right?
Yeah.
Turn in button.
Oh, it's here. Can you see my screen?
Jenny, we don't see
Yes,
you.
we can.
Wait, so you see the Onshape, right?
Right.
Yeah.
Okay, good.
So go to your email, which is gmail.com, and go check your email.
So I click here, right?
You don't click anything.
You go to your email.
Address bar. On the very top, there is a plus, right?
A plus, a plus.
Go
Yeah,
up.
I'm going up.
Go look at the very top.
I'm at the very top already.
Okay, right next to sign up -Onshape, that tab. Open up a new tab. Yep, that
Okay.
plus sign. Yep. Then type in gmail.com.
So what?
Gmail.com.
Okay. So go to my Gmail. Yeah.
Oh, yep, or that. Go to your email. And there should be an email from Onshape.
Oh,
Yeah, right there
yeah, this
with the new.
Onshape account is ready.
Yep, like that.
So I click that.
And
Activate your
activate
account,
your
right?
account. Yep.
Yeah, just click that big thing.
La-di-da-di-da.
Thing.
Then it asks you to pick a username and password, okay? You already have your username. You just need to pick a password. Make sure your password matches the criteria. Make sure you remember it.
That's my username. Okay.
Yep, that's
Password.
your username.
You should stop sharing your screen so you don't
Yeah,
see
you
your
can stop
password.
sharing.
Okay, you can't see what her password
I mean,
is.
no, yeah, you can't.
Look at the right-hand side. It says 8 characters minimum, 1 number, 1 lowercase, 1 uppercase. Okay, you have to fit
Password
the
requirements. 8-character minimum. One lowercase and 1 uppercase.
Is there anyone who is not done yet? Kylie,
Give
you are
it some
done,
thought.
right?
Make sure you remember what it is, okay?
Write on the piece of paper of your password, yeah. Don't forget it.
Okay.
Yep, the top and bottom has to match. Good.
Great.
Success.
And go ahead.
I don't have a phone number.
Good.
Yeah,
Oh,
can
use
you
your
please-
mom's. And you can stop sharing now because the phone
Yeah.
number it'll show. Stop sharing.
Yeah, sure.
Make sure you check that checkbox saying you read and understood the user agreement.
So just check that, okay.
Yeah.
And then I press get started. Huh?
Yep.
Okay.
Once you do that, you should be able to take you back to the
I can't hear you.
Yeah, you cut out.
home.
Yeah, Coach, we can hear you. She's still here? Yeah.
Yeah, I'm there. It says welcome to Onshape. You can get started by clicking the create button. Yeah, where is the create button?
Yeah, wait, that means you're done. You're fine.
Yeah, you're in.
Oh, great. Okay. Thank you.
Coach, are you still here?
Means you're.
Okay.
Do you guys hear me okay or no?
Yeah.
Yeah,
You
we
cut
can
out
hear
for a
you
bit
fine.
back there.
So now if you don't have questions, please keep yourself muted. If you have questions, you can raise your hand first and ask Coach Wang. Thank you.
Everybody go.
Cannot really hear you,
Let me go try something.
It says that your network bandwidth is low.
So now I assume everyone has set up your Onshape account, right? You have already signed up?
Oh, this is awkward.
Okay, that's better.
This machine doesn't actually have a Ethernet port for a hardware plug. All right. I have to go back.
How do you get started on Onshape?
Be there in a second, okay? Okay. Okay, I've turned my video off, and hopefully this will be a little bit better speed-wise. You guys can hear me okay, right?
Yes.
Let's get back to screen sharing.
I can hear you.
Okay. So since we're done here, let's go into Onshape. Need to refresh my screen. So this is the thing you guys saw a little bit earlier. It was running an animation. So let's.
I don't see it. On my screen, it just says Lee Wong has started screen sharing.
I can't hear anything.
I don't see anything.
You don't see anything? Because
I see a blue thing with red bolt things with the gold handle.
Yeah, that's what you're supposed to see.
Yeah. No, I just see Lee Wong has started screen sharing. I think it's my network.
Yeah, something's up with yours.
Then reload then.
Yeah, try to refresh or something.
You can't, I don't think you can reload Zoom.
Yeah.
Besides leaving the meeting and coming back, there's nothing in between.
If it were a network thing, wouldn't he have like disconnected from Zoom or something?
No, because Zoom is torturous in that way. Even if your network's low, you just lag a lot.
Right.
What's happening?
Okay, let's move on.
Screen share.
So when you hit the Onshape button on your upper left-hand corner, or rather the symbol, it'll bring you to your basic file storage area. Okay, so you guys should have a blank screen, more or less. So to start out with, let's try to be more organized. So click on the Create button, a drop-down menu shows, and go ahead and create a folder. Okay. I already have a 3D class thing, right? Well, okay, I'll call my 3D class folder. See, the most recent accessed file or folder always shows up on the very top. So once you have your folder created, go ahead and click on that. So you can get into an empty file management space. Okay, everybody there? Okay, since I don't have any questions, I'm assuming everybody's there. So to start out a new file.
Made my folder.
Great. Click on Create again. It says Document. Okay. I'm going to call my basic shapes. Everybody got here?
Yep.
Good. So this is called a workspace. Okay, let's go over a few definitions. So you see these three blue things in the middle. Those are work planes. Okay, each one of these is a plane. So this is the top plane. This is the front plane. And this is the right plane. If you understand coordinates, this is your X, Y, and Z. Okay? The point in the middle is called the origin. Why is it called the origin? Because all three planes intersect at that one point. This is the center of your screen, of your workspace. Okay, so on the left here, there are a couple of options you can do. All right, every single part, every single operation you do will be listed on the left panel. So you have right now the 3 planes and the origin. You can choose to turn them on and off, right? See the little eye shows up? If you click on it, a crossbar goes through the eye, you no longer see the plane. Okay, sometimes that is useful. Especially in 3D drawing, things tend to get in your way. So that's how you hide them, okay? Or temporarily hide them. So for today's exercise, let's try to draw some basic 3D shapes, okay? Now we'll do some 2D stuff. Most 3D shapes are generated from 2D drawings. 2D drawings are called sketches. And 3D drawing, that turn 2D things into 3D objects. So let's start with, actually, are you guys more familiar with millimeters or inches? I like inches.
I like
Inches.
Inches, good. That's a little easier for me to deal with. So before anything
I
starts,
can't see.
can you go get your mom and have her help you out real quick?
Okay.
All right, Leon.
I'm disappointed in all of you. Nobody here is from the millimeter gang.
Well, that's
Except
just
you.
a
I
different
am.
convention. You don't really need to be disappointed in anybody.
We have taken over.
So up here, you see the 3 bars right next to the unshaped symbol, right? So this is where you can define your workspace. So you can pick your document property, and you can write a little bit of description of what this document is. You don't have to, but if you have a lot of drawings you need to deal with, this does come in handy, right? So you can just click on that, and even in the file management area, it'll tell you what it is, right? So for our practices, we don't need that. So the important thing here is workspace unit. Like I mentioned, this entire screen right now is called a workspace, okay? So in my screen right now, the default length unit is inches. It'll measure the length up to the 3rd decimal point. So if I measure something that's 1 inch long, it'll tell me 1 inch 0.000. Or if you want to tell me 1 1/8, you tell me 1.125, up to 3 decimal points. Yeah, you can switch this. Okay. So default angles in degrees, and by decimal points, 3 decimal points. Default mass units in the English unit, which is pounds, and you can pick kilograms, grams, et cetera, et cetera. So for my purposes, I'm more familiar with inch and English units because I know how long a 1/2 inch is and how long a 3 inches is, okay? If it's more convenient to you to measure it in millimeters or centimeters, feel free to change it here, okay? And with that said, let's start by a basic shape. Let's draw a cube, okay? So click on sketch. The first thing you can show you that sketch 1 shows up in red because it's missing some parameters. So the first thing you need to define is what plane you want to draw, okay? So let's say I want to draw on the top plane. You click on that. Once this is selected, you notice that's not red anymore. Okay, that means it's happy. So drawing in 3D space is a little odd because everything seems a little bit obscure, right? So how do we change that? Let's turn into 2D space so I can see a little better. So you right-click on the plane of choice, which you choose was the top plane. Also shows you up here in the corner it says sketch 1, right? Click on the right-click on that plane. On the very bottom it says view normal to the sketch plane. Go ahead and click on that. Got it?
Wait, what?
Right-click on the plane. On the bottom it says view normal to sketch plane.
It's not working.
Click on that. Okay, let me go back to the beginning. All right, cancel that. I'm going to go back to the isometric view, the 3D space, okay? I want to start by drawing a 2D sketch so I can make this into a 3D object. So I click on Sketch.
How do you get to there?
Okay, then I'm going to
Oh.
Did I do something?
let me get to a better spot.
Turn it off. I need you to turn it off.
Turn it off. I already turned my thing off.
I pressed the play button. Then what do I do?
Marcus, turn it off now.
Stop. You're talking. Everybody can hear you.
Can you please mute yourself?
Okay, you guys can still see the screen, right? I'm not sharing anymore, am I?
All I see is a
Yeah, no, because I'm pretty sure you're disconnected. So
Yeah, I did.
yeah, so
Sorry.
we can't.
Okay, I'm gonna start back up, okay? Okay, I'm working with one screen now. Hopefully, this will still work okay. It should be all right. So we hit sketch, right? You can see you can choose one of the 3 planes to draw your sketch on. So I'm gonna pick the bottom plane. Okay? Once you hit the bottom plane, right here is the top plane rather. It shows you on this corner here is top plane. That's what you're gonna be drawing your picture on. Okay? You right click on that plane. It says view normal to sketch plane. Got that? So this will get you into a 2D drawing space. So you can see things that's no longer askew. Everybody got there?
Yeah.
Okay. So for starters,
How do you get there?
Okay, did you get the sketch part?
How do you get there?
Okay, how do I did you get to the sketch part? Okay, let's
How do
do
you get
this
to the
again.
sketch part?
Nice and slow, okay?
Okay.
Let me go back to the 3D space. This is your 3D workspace, okay?
Yeah.
To turn your 3D space, you hold down to your right mouse button and you just drag, okay?
Okay.
To shift around, you hold down to your control key, then you hold down to your right-hand mouse button, then you drag. Got that?
Okay.
All right. So now underneath the unshaped symbol on the upper left-hand corner, you see a sketch with a pencil symbol. Okay? Click that. A little window shows up.
I don't see it.
You don't see it. Maybe you're already on it. Okay, does your screen look like mine right now?
No.
You care to share?
What screen are
Okay.
you on?
Go ahead and share.
Okay.
Ah,
Gotta press create.
Then.
document.
Document.
Give it a name, whatever name.
Okay.
Click OK.
So
Go ahead
just
and
X that
close that
out.
out. Yep, just X all those out. For the first time you go in, they'll give you some pointers. Okay, now you're on the space. Go ahead and stop your sharing. All right, let me get back to it. So this is the space you see, right? Everybody got how do you move around in your workspace, right? How do you rotate your model around, your workspace around? How do you move? How do you pan? Okay. So let's get back to our sketch. Notice when I hit sketch, an item showed up on the left-hand menu bar, okay? So once you're there, pick your sketch plane. This is your sketch plane. Pick the top plane. Then you right-click on the other rectangle that showed up and it says View Normal to Sketch. Right? Everybody got here, right?
Can you go over it again?
How do you get there?
Can we do the same things that you do?
Okay. One last time. We're taking way too much time on this object here. So everybody got to the workspace, correct?
Yes.
Yeah.
Good.
Yeah.
Upper left-hand corner, underneath the unshaped symbol, there's a pencil with a sketch written right next to it. You see that?
Yeah.
Click that. Okay. Then a little screen shows up, little window shows up. It says red, sketch 1, with a green check and the red cross, right?
Yeah.
There's one field that's highlighted in blue. It says sketch plane.
Yeah.
You pick the plane. You click on the blue part. Then you navigate to your screen and hit top plane. Then another light blue rectangle shows up. This is your drawing plane. Okay?
When I press on the blue thing, nothing happens.
Doesn't matter.
Okay.
Once you click on the drawing plane, that part shouldn't be blue anymore, right? It says top plane in that field.
Yeah.
Okay, good. So right click onto sketch 1 plane. A manual shows up. Hit view normal to sketch plane. We got that far?
Yeah.
Very good. Now let's draw a square, right? What is a cube? A cube has 6 sides of the same size, right? So there are 2 ways we can draw this rectangle or square. One is a corner rectangle. Okay? Meaning you can pick one wherever you want that corner to be and open it up. See how that just happened? You draw a rectangle. The other way to do it is a center point rectangle. Okay?
How do you do that?
You hit on the little arrow on the side. It gives you choices. okay?
Little arrows.
Center point rectangle. So what does that do? So once you choose that, whatever point you click on is the center of the rectangle. See the difference?
Mm-hmm.
Okay. So now we have two rectangles drawn. So we only need one. So let's go ahead and get rid of one of them. So now the rectangle is drawn. Let's give it some sides. Okay. So what you do is, this is a dimension tool right toward the middle of the manual bar on top. It says dimensions. See that? Click on that, it turns blue.
How do you delete things?
You highlight it, then you use your delete button on your keyboard.
It's not working.
Well, okay, you want to share your screen real quick?
It says none of the selected identities could be deleted.
Well, if it's highlighted as orange, then you can be deleted. I'll go over that stuff with you later, Liam. So let's just keep going. So this, notice once a rectangle is drawn, the software shaded what it enclosed, right? This is an enclosed area. This will become important in a minute. So let's give it some dimensions. The dimensioning tool is blue. So you can highlight the area you want to give it dimension. What dimension means is size. You want to tell you what size it is, okay? So right now, this part is 2.39 inches. I want to make it 2 inches. So on your keyboard, type 2. Okay, enter. So now the rectangle will go to shape. Okay, go to the size you asked it to. So you click on the right-hand side. It shows 1 point something inches. I want that to be 2 as well. So we have a square. Okay, everybody got there?
No, well, I'm confused how to do that.
Okay. The idea in Onshape is you draw something close to the actual shape first, and then you define the size of it. So let me go ahead and delete everything. So you use your left-hand mouse button, hold your left-hand mouse button, then you drag a rectangle, okay, like that. You can close everything in the area. And go ahead and you hit the delete button, it deletes it, right? So let's go back to the how to draw a rectangle again. So I'm using the corner rectangle, okay? So notice the drawing rectangle button is blue. So that one is selected, is highlighted. So now you're ready to draw the rectangle. So hold down to your left mouse button, click, and drag. You have a rectangle drawn. Okay? Once you're there, you can go ahead and define the size of the rectangle. Since we want a square, we'll define the size of the sides. So you click on the dimension tool, which is in the middle of the top menu bar, as 2 lines and a couple of arrows. That's what dimension symbols looks like. So you click on the side you want to dimension, and this will show you how long currently it is 2.94 inches. I want it to be 2 inches. You just put in 2. Then you hit enter. So the rectangle would change size in turn. And then we can do the other side as well. Define this side to be 2 inches. Now we have a square with 2 inches on either side. We good here?
The dimension tool isn't showing up on my toolbar.
Your screen resolution might be a little small. There should be a either left or right arrow on the very top. You can use that to scroll. Seeing it?
No.
Okay, go ahead and share your screen.
Okay. This is the thing.
How do you align things?
Because you are not in sketch space yet.
Ah, that would make
Right.
a lot of sense now.
That's right. Go ahead and double click on sketch 1. They'll get you back into that space. Go to the left side menu.
This one?
Nope, keep
Wait,
going
no.
down. You already did it. It says
Align
sketch
the
1.
dots.
Double click on sketch 1.
Ah, there we
Now
go.
you're-
Okay, thank you a lot.
Go ahead and stop the share. Good.
Thank you a lot. There we
How
go.
do you align the dots?
How to align the dots. Can you share your screen and tell me what you mean by that? Okay. Good. That's it. You did it. That's a 2x2. You don't need to worry about that yet. We'll worry about the locking stuff later, a little bit later. So one step at a time, okay? Go ahead and stop your share. Okay, I think everybody's ready to proceed, right? We have our 2x2 square on your screen. So there are a couple of ways to how to generate, actually several ways, how to generate a 3D shape out of a 2D sketch. Okay? Today we'll do two. One is called extrude. The other one is called a revolve. Okay? Extrude, basically like how it sounds, it moves on a single axis. Okay? Let's do that demonstration real quick. So we have our 2x2 square that's shaded. That means that is an enclosed area. So you can make a solid shape out of that. So go back, you can go ahead and check the green check mark on sketch 1. Now you get you back into 3D space. Okay? If you want to roll around a little bit, you can see that's a 2D sketch on the top plane.
That was my extrude.
Right? So go ahead, right next to the sketch button, there is a extrude button. It looks like a square with a cube on top of it. Click that. Extrude 1 should show up. It gives you a few choices. You can either extrude a solid or a surface. If you have more than one object, you can add to it, remove parts from it, or whatever intersects it, and keep something that's there. Okay. So since we're doing the simple part, we're just going to leave the as a solid, a new part. Okay. Right now it is red. When it's red, that means something is not right. It's not happy. So if you look at the part that's highlighted in blue, it says phases and sketch regions to extrude. So you have to pick what you want to extrude. So let's pick our rectangle. When you roll over with your pointer, it turns orange, right? You click on it. Boom.
I can't turn around my thing.
So now, if you look down further, there are other choices. How deep do you want this extrusion to be? On the drawing, you can see there's an arrow, right? That's the way the extrusion took place. It's still sitting on the top plane. It extruded toward the top. And you can actually turn this direction by clicking and highlight. See that when I roll over it, the arrow turns orange. If I click on it, it'll go the other way. Okay?
Where did you get the square like that?
This is called extrude, okay? Please pay attention. I can't keep going the same stuff over and over again and while other people are waiting. I'll do this again in a minute. So depth is how you define how far the extrusion is. Right now, the default is 1 inch. And our square on the face is a 2 by 2. So if I want to have a cube of the same size, I got to make that 2 inches. Okay? Then boom. Now I have a 2-inch cube. Once you're happy, you can click on the green to accept the shape. That's a cube. Okay? So let's do that again. Let me go ahead and delete the extrude. Go back to our sketch. I highlight the sketch. I say I want to make a cube out of this sketch. I go to this menu item that's right next to the sketch button, which you clicked a minute ago, to draw the 2 by 2 square. So you click on that. A little menu shows up asking you, well, since I already highlighted thing, let's do from scratch. Click on that. It's asking you in the blue area, what do you want to extrude, right? So you click on the rectangle you made, or rather square you made, and it extruded this way, okay? So I wanted the 2 by 2 by 2 cube, so I have to go to depth field, put in 2 inches. Now you have a cube. Once you're happy with that, go ahead and click check. Now you have a cube.
Yay.
We got that far?
Yes.
Very good. So this is how you made a cube by extrusion. Now what does revolve do? What revolve does, go back to our, let me go ahead and delete the cube. Go back to our design on the top plane. Let's be normal to it. So what does revolve do is you revolve this shape around a certain axis. Imagine if you had this rectangle square here, if I have a line here, it wanted you to revolve around that line. It's 360 degrees. What do you think you're gonna get? You're gonna get a cylinder with a hole in it, right? So let's draw a line on the same plane. Actually, yeah, that's a new sketch. On the same plane, I want to have a line, a vertical line here. Doesn't matter where. Okay, this is a line I wanted. Doesn't matter how far it is for our purpose. So I want this to revolve around that to generate a 3D shape. So I go ahead and click check. There's the next button right next to extrude. It says revolve. Click that. A menu shows up. Face and sketch region to revolve. Okay, I want the square. Revolve axis. Click on that. Highlighted blue. I want this line to be the center point of my revolve. And full just means the full 360 degrees. So now this shape is generated. What does it look like? It's a donut.
Taurus time.
Yep.
Can you go a little slow? It's a bit hard to keep up.
I know how to make it even more look like a donut.
Can you go a bit slower? It's kind of hard to keep up.
Okay, let's do that again, right? Is that the question? Okay. I'm gonna go ahead and delete the donut. So, did you get how I drew this line?
No.
Okay, let's get rid of this too. You got this far, right? You got the square on your paper, correct? In your workspace. Okay, good. So since I wanted a rotational axis, so I want to sketch another line. So we go back to sketch, pick the same plane my square is on, sketch plane. Then you pick a line, right? So you just draw the line vertical.
Wait, yours says top plane. Mine still says sketch plane.
Doesn't matter. So long as the same plane. Okay, that's how I got the line. Good?
Not really. I don't know where the line is actually.
Okay, let's go ahead and cancel this. Let me get back to 3D space. See the top plane where your square is on, correct?
Yeah.
Okay. Go back to sketch, click sketch button. A new little sketch button shows up, says sketch 2.
Yeah.
Ask you to select the plane. You select the same plane where your square is on, which in my case is the top plane. Right? Then another little rectangle shows up. It says sketch 2. That's the drawing plane. So you do the same thing as how you did the square. You right click on it and go to view normal to the sketch plane.
Yeah.
Good? Okay.
Yep.
Oh, we draw a line. It doesn't really matter where. Okay. Draw a vertical line. Vertical means up and down. You click it and then you drop it down. Okay. You can do a couple ways. Okay.
Okay.
You can either drag and drop like this by holding the mouse button, or you can just you can make the first point and let go of the button. It'll do the drag itself. Okay?
Okay, got it.
To finish, you don't want to draw the second line anymore. Right click and it says escape line. Or you can use the escape button, the same thing.
Press escape line. Yeah, okay, got it.
Good. So now you're ready for the revolve. Go ahead and check the green check on sketch 2. See, once it's black, it's satisfied. It's happy.
Okay.
So you have a rectangle, you have your square, and you have your line right next to it.
Yep.
So go ahead and hit revolve,
Hit revolve.
the top menu.
Wait. Yeah, okay.
Back to extrude. Okay. It said
Wait,
phase.
what do you do?
Okay, let me close this. Revolve, right next to the extrude button. Okay.
Yeah.
Okay. Leave that default setting. We'll explore the other ones later. Okay. Right now, the highlighted blue says phase or sketch region to evolve. You choose your square. And now the revolve still red. It just showed you another red field, right?
Mine doesn't actually look like that.
Okay, let me finish, then you can show me your screen. Let me see what's wrong, okay?
Okay.
You click on that turns blue. You pick the line you drew. Now that generated the 3D donut.
Mine looks like a tire.
Sure. And you can do the check mark, just saying, okay, this is done.
I used a fillet.
Okay, let me stop share, and Jenny, you can show me your screen, see what's up there.
Okay. Mine looks like this.
Which is fine. Okay.
Huh?
See the
Okay.
red part that says face and sketch region? Click on that. Right, then click your rectangle. Or your square, rather.
Square.
Yep. Just, no, not right click, left click.
Okay, left click.
There you go. Now the other thing's not happy, right? Revolve axis. Pick that. Click on that. Yep.
Yeah.
And click your line. That's how you pick your axis. You can go ahead and click on your right-hand button or scroll down and drag it down. That's how you roll it. There you go.
Okay, thank you.
Good.
Oh dear. Well, at least I can do it again.
Yep. Practice makes perfect.
Can we leave?
At least I hope so.
Were you bored?
It's not 8:30 yet. So no.
You're actually doing
Okay.
a good job. Yeah,
Who was that, Michael?
I think so. Yeah.
Michael wanted to leave. I told him it's not 8:30
All right,
yet.
10 more minutes, okay? So how do you add the two shapes together? We have an evolve. Well, this shape probably won't make a whole lot of sense, but we can try it. We have an evolve. That's going to use the same sketch. And we can make an extrude. All right, so we use the same shape we drew. Hopefully we can get to it. Let's use add to the cylinder. There we go. Okay, and make it a little bit longer, say 4 inches. This is just for fun. Okay, and boom, what do we have?
Hey.
Yep,
It sort of looks like a leaf blower, but with a short nozzle.
yeah. So this is actually looks kind of like a fan body, a shell. Let me just show you something for fun. We can work on that later, okay?
It also looks like tape.
So there is a shell button here. All right, a little bit further down your menu. You click on that.
How do you do that letter A?
Okay, let me just show you the shell real quick. This is kind of fun.
Okay.
So you click on the face you want to get rid of, which is the square face right here. And then boom, what do you have? You just made a shell out of the whole thing. See that? So now you're actually designing something. All right,
Can I show you my tire?
in a minute. Let's go back to how we did the A, or you want to call it an A. So go ahead and go back to your sketch 1, right? Click on that, left-hand click on that. When you did the revolve, it automatically hid the sketch 1. So you need to see it again. See, there's a line across the eye. So
Wait, what do you
click
do?
on
So
the eye,
wait, so you click sketch 1, yeah? Click sketch
Yep.
1.
and make sure the eye is showing versus the eye was across.
Yeah, and then you click the eye, right?
Yep. So now you can see the square on the top plane now, right? So if you have it crossed, you won't be able to see it.
Wait, so you click sketch 1, and then you click the eye, and then?
Yep, now you can see the shape in there, right? You can see the square embedded
Where?
into.
I can't really see it, actually. Let me
Okay.
just move around and see if there even is a square. Nope, I can't see it.
Okay. Go ahead and roll over sketch 1 on the left-hand menu.
Roll over sketch 1. Was here what?
Right. Is your eyeball showing as an eye or does it have a line in it?
It's got the sideways line in it.
Okay, click on it again. Click on the line.
Okay.
Now it shows an eye, right?
Yeah.
Okay, then go back to your model. Do you see the square yet?
Let's see. No. Wait, I think I see it.
Yeah,
Nope.
there you go.
I'm not sure if I see it or not. Maybe I should share
Can you
screen.
wait a little bit? Let the coach Wang continue.
Yeah. Let me finish this. You can stay after
Yeah.
class a little bit, okay? I'll show you.
Thank you,
You
Jenny.
can share the screen then, Jenny. So let's do an extrude operation on this shape, right? So we want to add to the donut. Choose add. And we want this shape to be 4 inches long. So go ahead and click this area, the blue, and try to, sometimes a little bit difficult to get to it. Yeah.
I'm not tired yet.
Sometimes is being difficult. Because it's kind of hidden. The other thing you can do is make this part transparent. Now you can see it. Okay. There we go. And you just hit the check mark. Now you got your A. Okay. Couple more minutes. So this is basic shape, 3D shape generation, right? You have your extrude and you have your revolve. So, just for fun, go ahead, Liam. You want to share?
Yeah, go ahead. Yeah, share your tire.
Go ahead.
Wow.
Good.
That looks awesome.
So what Liam did is fillet, okay, which means it cuts off a sharp angle. Okay, do you want to show the guys how to do that, Liam?
Yeah.
So you have your shape. You pick a face to fillet. And you can, yep, do both. Then you can change your radius, how big you want the fillet to be. And now you have a real donut. Or a life ring. And you can click on all the sharp edges. I think you got them all. Click the check. Oh, he just deleted it all.
This is cool.
Nice, yeah.
Good. Go ahead and stop your share.
Very nice. Thank you for sharing, Liam. That's amazing.
So you can do it to our alphabet too, okay? So you can either do it by the edge or you can do it by the face. So let's try to do the face first. You can click fillet.
Okay, I'm leaving.
Okay, bye-bye. So now I just filleted the whole face. Every single edge on that face is filleted. So you can change the size of it to 1/2 inch. So the bigger the number, the more material it will remove. So of course you make it too big, it'll show up as red. Because this edge, it doesn't have enough meat for you to cut. Okay, so 1 inch is not even good enough on that one. So we do 1/2. So that's this phase. I can do this phase. Now everything's rounded. Okay, that's your first object. So feel free to play with the software and you can generate all kinds of different shapes. Use your extrude, use your revolve, and the fillet we talked about. And if you want to get fancier, try the shell portion. So you click this, you can include all that now. No, it doesn't do the wrong things. Let's get rid of these. See, that makes a shell of the part you made. Okay? So mess around. Like I said, the help menu in Onshape is actually really helpful. If you are curious about what all of these little functions does, feel free to read through the help file. It'll take you a little while. And you know, practice, play with it. The more you mess around with it, the better you'll be at it. Let me show you what Kevin did on his own before this class even ever took place.
Can
So
I share a sphere?
just 1 second, okay? Kevin went on YouTube and learned everything, learned a lot about Onshape and how to draw the 3D designs. So he drew his own Rubik's Cube parts.
Nice.
Right? So this is all the little parts on the Rubik's Cube, and these are the pieces, how you assemble them together. Right? You got your edge piece, center piece, you got your core, and you have your cap here. Okay? So you can do a lot with Onshape on your own, and he also drew up this Captain American shield, and this is a keychain. Okay. And YouTube is also a very good resource if you want to learn some basic stuff. And we'll go over, well, the idea is go over some basic stuff. And so you guys can generate a part of your choice, and then we can 3D print it. And you can keep it as a souvenir or otherwise. So as a experience item, right? So you learned it, you used it. For those of you that are interested in getting your own machine, and of course, you know, hopefully this will be a gateway, entryway to help you out in the long run. So with all that said, any of you that still have questions, want to stay, feel free to stay. I'll answer some questions.
Is it the field?
Oh yeah. Okay. Do you want to share with? Okay. Nice.
Okay, let me stop the share. So Liam has something to share, right? Go ahead. Ah, nice. So he used one way to draw a ball, a sphere.
Nice.
He extruded the cube and he just used a fillet operation to cut off all the corners. Now there's another way to use the what we learned today to draw a sphere, okay, which is using revolve. See if you can think about that and you know, draw a sphere using revolve. Okay. It's actually a one-step operation, and it should be a little easier. Okay, with that said,
Can I leave?
if you're happy with what you got, go ahead and leave. Class is over.
Yes. If there's anyone who wants to share your design, you can share right now if you want.
Thank you. Bye.
Okay. Thank you. Bye.
Yeah.
So Jenny, you have a question, right?
Yeah.
If
Okay. Thank
you
you.
have questions, you can stay, and we'll talk about it.
Farewell.
Thank you very much.
Okay, Jenny, go ahead and share.